graphs of sine and cosine. So, just like back in Algebra 1, when we were first introduced to linear functions, we can do the same thing with trigonometric functions. Linear functions, you probably were asked to plug in the values -2, -1, 0, 1, and 2. And you later found out that actually I only need 2 points, and if I just know the slope of the equation line and then the y-intercept, that's enough to graph it. But it's the same thing with these. You can, there's some shortcuts based on the parent graphs and shifting rules, and I'll show those to you. But what it comes down to is you can plug in values, and guess which values you plug in? Yeah, these same. Well, no, yeah, right here. The ones that you're memorizing on the unit circle are the ones to plug in. As a matter of fact, you probably want to plug in ones that are at the 90-degree or pi/2 multiples, because those are all zeros and ones. And we'll find out that that's usually sufficient for graphing. Although, if I start changing the period, then I need to maybe plug in some of these other values. So that's what we're going to do. This is, we'll go ahead and we're going to create a table here. So I'd like you to make an XY table. And we're going to plug in the values for x, 0, pi/2, pi, 3 pi/2, and 2 pi. And just go ahead and see what values we get as outputs when we plug those in. So here you have to know your unit circle. So sine of 0 is 0. Good. Can you picture where we are on the unit circle? Far right, okay, we're 0 up. Sine of pi/2, 1. Okay. And then sine of pi is 0. And sine of 3 pi/2 is -1. And then sine of 2 pi is back to 0. And that is the graph of one cycle. So if I start right here at 0, here's how you're going to label your graph in radians from along the x-axis. Is you're going to go up, at least for the parent graph, by pi/2. So the first little tick mark will be pi/2. The second one will be pi, and then 3 pi/2, and then 2 pi. And of course you could go the other direction along there and label it. This would be -pi/2 right here, and then it would repeat itself and keep going. As a matter of fact, we're going to only graph one cycle of this. You may already know that, especially if you're in physics, that trigonometric functions are periodic, meaning they repeat themselves over and over again. They're cyclic, if you will. Okay, they just keep cycling through. We're going to draw just one cycle, and that's what I'm going to have you do in the homework on 43 to 45 after the matching. It's just draw one cycle of sine or cosine. I'll give you several examples of that. So right here I have 0, 0, there's a dot. At pi/2, I'm up at 1, so I probably should label my y-axis here. We'll call that 1, and down here -1. As a matter of fact, with sine and cosine parent functions, I only need to go from -1 to 1, because think about it on the unit circle. The biggest value you could have is 1, the smallest is -1 for sine or cosine. All those values like √2/2, √3/2, or 1/2 are all values that are less than 1. So the biggest it can be is 1, the smallest it can be is -1. So I'm going to go up to 1 here at pi/2. At pi I'm at 0. At 3 pi/2 I bottom out at -1, and then at 2 pi I'm back at 0. And so what I've drawn right there is one cycle of the sine function. It's one cycle. And then you might want to just make some dashed lines just to show that it does keep going. And it just keeps following that same pattern. But the solid one is our one cycle. Okay. Let's do a similar thing with the cosine function here. So cosine, if I make a table here for cosine, so we'll have x and y. I'm going to plug in the same values. 0 pi/2, pi, 3 pi/2, 2 pi. And we'll get different values corresponding to these. The same zeros and ones and -1s will show up at different places, different angles. So cosine of 0 is 1. cosine of pi over 2 is 0. Cosine of pi is -1. And cosine of 3 pi over 2. And then cosine of 2 pi is... So, you can see now why it's good to know your unit circle well. So starting right here, I'm going to go up to 1 and down to -1. I'm going to scale it by pi over 2's as I go from left to right. Put a couple more values there on the negative axis just to show what would happen as it keeps going. I want to demonstrate to you or show you the relationship between these two as well. So 0, 1. We say the parent graph of cosine starts high, whereas the sine parent graph starts low. It starts at the origin. Cosine starts high at 0, 1. And then it drops down to pi over 2, 0, and then at pi it bottoms out at -1. And then at 3 pi over 2 it's up to 0 again. And then at 2 pi it's up to 1. And so here's one cycle of the cosine function. It keeps going here. Got a little farther this time. I left a little more room. Now, there's a relationship between these two. I'll let you finish drawing it. I'm going to go ahead and... You won't be able to do this. You have to have a smart board to do this. But I can take this guy right here. So I'm going to take my whole function. And if I just take this whole function, you'll see that it does match up with this, well, for the most part. But all that I have to do to make this match up is just shift it over. There's the cosine function. If I shift it over, how many radians? So here it is right here, right? Shift it from there over to there. How many radians did I shift that to make it match up with the sine function? Half a pi, yeah, pi over 2 or 90 degrees. So it is said, you may have heard this said before. Oops, I lost my dot. That's because that's the sine function. They separate it here. Yeah, that was the sine one, huh? Let's try that again. There it goes. Okay. So, yeah, the difference between the two is just pi over 2 radians or 90 degrees. As a matter of fact, you can model the same data with either cosine or sine. You just do a horizontal shift of pi over 2 and then match up. So oftentimes you can choose one or the other and when you're doing mathematical modeling. Now the domain and range of each of these are the same. The domain is -infinity to infinity. You can plug in any angle. So all real numbers, you can plug in any angle you want. There are no restrictions like logarithms had. Remember, logarithm functions, x had to be strictly greater than 0. That's not the case here. Any input you want. But the range is limited. It goes from -1 to 1, at least for the parent graph. And that's because opposite over hypotenuse or adjacent over hypotenuse, which are the definitions of sine and cosine, cannot be bigger than 1. The biggest length on the unit circle is the radius, which is 1. So that's another reason why we know sine and cosine, which make up the x and the y on the unit circle, cannot be bigger than 1. All right. We call this piece right here, you've probably heard this term before, especially thinking about music and speakers, but amplitude, it's the distance, positive distance, above or below the center of a function. We usually use the letter A. It's like you take the absolute value of A is the amplitude, and the amplitude is always the number out in front of the function. It will affect the vertical stretch. So just like with quadratic functions and square root functions, that number out in front of the function affects how much it's stretched vertically. That's what amplitude does. And we just look at the, it's just the distance from the center. Sometimes we call that center the midline. In this case, the center happens to be the x-axis, but if I shift it up or down, the center is no longer the x-axis, it's something else, some other horizontal line. And then the period, it's the cycle every 2 pi radians. So the period is, we actually get it, there's a relationship, an expression that we use that relates the number in front of the x in the function to the period. So it cycles every 2 pi radians. In this case, it's right here, this number in front of the x here is called b, and we have a formula for finding the period if we know b. And then right out in front here is a. In this case, for cosine and sine, both a and b are 1. So for the parent graphs, they're both 1. Yours has b's on here, so I'll change these to b's. So sine of bx, b is the number of cycles in 2 pi. So in this case, with the parent graph, we have 1 cycle in 2 pi radians. But if you change this number, say, to a 2, then you'll have 2 cycles in 2 pi radians, meaning the period is no longer 2 pi, but actually half of that, or pi. So it's how many cycles you have. That b is how many cycles you have in 2 pi radians. And each period has a length of 2 pi over b. So with our trigonometric functions, we're just going to use a, b, c, and d to represent our different stretching and shifting rules. So a, b, c, and d rather than Greek letters. So getting away from the omega here. So b represents the number of cycles in 2 pi, so it's related to the period. And then a, that number out in front, is the amplitude. Sometimes I'll use a lowercase a. All right, so on your sheet, you have a whole process for graphing. You have the graph of y equals a sine of dx, or y equals a cosine of dx. And then it says there's 4 steps there. So we're going to determine the amplitude and period. So that's just a matter of reading it off the graph. So in this case, absolute value of 2 is equal to 2. So that's the amplitude, a here. And then to get my period, the period is equal to, we use this little expression right here, it's equal to 2 pi divided by whatever is in b's place in the equation. In this case, in b's place is a 1. 2 pi over 1, which is 2 pi. So the period is the same as it was for the parent graph for this one. And then the next thing I asked you to do was to figure out the intervals, to split it up into intervals. So what we're going to do is divide the period by 4 intervals, because we want it to correspond to what we did up here. It's like this is where you're starting, 1, 2, 3, 4 intervals. So we're going to split it up into 4 intervals, because as we see with the parent graph, at each quarter interval, we hit a key point, like either a high point, an intercept, or a low point, and then back to where we started. So that's why we're dividing by 4. So we'll take the period, and we're going to get the increment by taking the period, 2 pi, and dividing by 4. And I get pi over 2. So that's going to tell me how to set up my graphing scale. Okay. All these are going to kind of look the same, just have different scales. So in this one, draw an XY grid. I usually make it the horizontal axis a little longer. My amplitude in this case is actually 2, so I'm going to go up to 2 or down to -2, because the amplitude is 2. That's the only thing that's really changing here. And then I'm going to scale this by pi over 2. So that's pi over 2, pi, 3 pi over 2, and 2 pi. Now, you're welcome to plug in values to the table. The only thing that's going to change here is that it's going to go up to 2 and down to negative 2. Everything else will look the same as the parent graph. So we know that at 0, 0, where it starts, for sine, it's going to start at the origin. It starts low, so it's going to start right here. At pi over 2, what's going to happen to this function? Yeah. It's going to top out at 2, right? And then at the next increment, what's going to happen? Yep, it's going to be at 0. In the next increment, it's going to go down to negative 2 and bottom out. And then next increment, it's going to go back to where it started. So there's one cycle, and that's what I'm going to ask you to do on the part of the homework, is just graph one cycle of these. So that's just changing the amplitude. Any questions on that?
So are they all going to look kind of like the parent graph?
Yep.
And you're just going to change like the scale and stuff like
Yep.
that?
And then tomorrow we talk about shifting it up or down and left or right, and then we got to redraw. It's like we're redrawing axes, but they still look the same, just with the redrawn midline or axis that splits it in half. So this next one, we have two things going on here. We're going to, or three, if you will. A is equal to the absolute value of negative 3, which is 3. So the amplitude in this case is 3. The period is related to, we get the period by taking 2 pi and dividing it by b. In this case, b is 2. So what we have now is a period of pi. So it's going to go through 2 cycles in 2 pi, but we're just going to draw one cycle, so it's pi. So that means my increment here is equal to pi over 4. So I'm going to count by pi over 4s in this case, up to pi. We got the cosine function here. Let's go ahead and draw our amplitude. It's going to go up to 1, 2, 3, and down to 1 to negative 3. And I'm going to count by pi over 4, so I go pi over 4. Next one would be 2 pi over 4, or pi over 2. And then 3 pi over 4, and then pi. Yeah, this one will actually start at pi. Now, the cosine function would start high. This negative sign right here is going to reflect the whole function over the x-axis. So where it would normally start up at, the parent graph starts at 0, 1. This one's going to start at 0, negative 3, actually, because I have a 3 there. So it's going to start right down here. Now, if you're not sure, when in doubt, you always have the option of making a little xy table and just plugging in values. I mean, if you plug in 0, just plugging in 0 will get you the starting point. You could probably go from there. So if I plug in 0 here, cosine of 2 times 0 is 0, cosine is 0. Cosine of 0 is 1. 1 times negative 3 is negative 3. So I start at negative 3 if I want to know, okay, what happens when I go to pi over 4, the first value in the increment? Well, if I plug in pi over 4 here, it's 2 pi over 4, which is actually pi over 2. Cosine of pi over 2 is 0. 0 times negative 3 is 0. So that gives me the first 2 coordinates of this. So it starts down low at 0, negative 3. It's going to go up to 3 at the pi over 2, then back down to 0 at 3 pi over 4, and then bottom out again at pi. So one cycle look like this, but you always have the option with the unit circle of just plugging in specific values that you've memorized. Try to plug in the ones that will give you your maxes or mins, or zeros. That's it. So there's one cycle of it. All right, now let's look at a sine graph where there's something here for B, and there's something going on with A as well. So let's see, the amplitude A is equal to the absolute value of negative 1, which is 1. And the period is equal to 2 pi divided by, now this is strange, we have pi in our B, yeah. So what this is going to do, let's cancel out the pi's. I'll have 2 pi times 2 over pi, which gives me 4. The pi's cancel. So what I have is a period of 4. A lot of the problems we'll do will have a period that's in terms of pi, but it doesn't have to. In real life, often there's no pi in there. It's just some numerical value based on the data. So, or how often it repeats. Like we're going to do a little mathematical modeling with tides. So in terms of tides are periodic. They're modeled by sine and cosine functions. So when it comes to tides, you might look at one high tide and then find the next high tide, and that would be your period. And it's not going to be some multiple of pi. So here in this case we have a period of 4. And then the increment comes out kind of nicely here. It's 4 over 4 or 1. And so there are no pi's in our scale here. Yeah, we got rid of them. So I'm going to go up to 1, down to negative 1, and this time I'm going to go up by 1 each time, all the way up to 4, because the period is 4. But the graph still looks, kind of looks like the other ones. Doesn't matter what the scale is so much. This is a sine curve. It's going to start, therefore, on 0, 0. But the negative is going to make it go down first. It's going to reflect it. So, yeah, 1, negative 1, it bottoms out. 2, 0. 3, 1. 4, 0. So there's one cycle. Let's do some dash lines to remind you that it is cyclic. It's going to keep telling me that my computer's running slow. It has been all. Alright. So any questions on those? Let's do just a couple more here.
It's just the same principles.
Yeah, it is. We'll do a couple more. Go through these fairly quickly here. But amplitude in this case is equal to 5 halves. The period is equal to 2 pi divided by 1/3. So remember, this is my B. I'm going to use that to find my period. It's not that 1/3 is not my period, but 2 pi divided by 1/3 will give me the period. So in this case, when I flip and multiply, I get 6 pi. So 6 pi is my period. My increment then is equal to 6 pi divided by 4. Or you could also think of that as 3 pi over 2. Okay. So sometimes the reason I have this example in there is sometimes this is the most confusing part, is counting by fractional values.
Yeah.
So I'll show you a trick for this that'll work. Most difficult part of the graphing section here. So we have a period of 6 pi. That means I need to start. I'm going to start at 0. I don't have to. I could, if you wanted to, you could shift it. But I'm not going to do that. I'm going to start at 0. And then we're going to count up to 6 pi. So we're counting by 3 pi over 2 increments. We should get to 6 pi eventually. What I would recommend is just counting by 3 pi over 2. So here's what I mean by that. If you count by 3 pi over 2 and then you have another 3 pi over 2, then the next one would actually be, don't simplify it, just leave it as 6 pi over 2. Okay? So 3 pi over 2 plus 3 pi over 2 is 6 pi over 2. And then the next one will be 9 pi over 2, right? Add another 3 to the just top, 3 pi to the top. And then the next one will be 12 pi over 2. If you want to, you can go back and simplify the 6 pi over 2 to a 3 pi and the 12 pi over 2 to a 6 pi, but you don't have to. your graph here. You can just leave it like that. Just count by 3 pi over 2. Yeah, you can see the pattern here. Go through. So, and then when I go to graph this, we have an amplitude of 5 halves. We'll just go ahead and do this. 5 halves, negative 5 halves. Sure, you can do that. And it's going to start up high at 0, 5 halves, drop down to 3 pi over 2, 0, and then bottom out at 6 pi over 2 or 3 pi, negative 5 halves. So at each increment it represents a different key value, either a max, a 0, or a min. And there's one cycle. That's it. All right, so let's quickly do this one here. A equals 1, period is equal to 2 pi over 3 over 2. All right. All right, and then multiply here. So we have 2 pi times 2/3. So that's 4 pi over 3. This is another one. I just added this in just because this is what we struggled with. So here we have this fraction, this period that's a 4 pi. It's not 2 pi, it's not 6 pi, it's not 4. It's something other than that. So it's 4 pi over 3. Can we still break it into increments? 4 increments? Yeah, it's not a problem. We just have to count by different fractional amounts, that's all. So we're going to take 4 pi over 3 and divide it by 4. That's the same as 4 pi over 3 times 1/4. So we end up counting by pi over 3's this time. So my amplitude goes up to 1, down to negative 1. I have pi over 3 as my first increment, and so let's count by pi over 3's here. So we have pi over 3, and then the next one will be 2 pi over 3, and then why not just write 3 pi over 3, and then 4 pi over 3, and we've got it. We know 3 pi over 3 is equivalent to pi, but leave it like that. And then this is a sine curve, so it's going to start low at 0, 0, go up to pi over 3, 1, down to 2 pi over 3, 0, down to pi negative 1, and back up to 4 pi over 3. So there's one cycle of that graph. But that's what I'm going to ask you to do in the homework, is dealing with just the period and amplitude and graphing sine and cosine. Eventually we'll add horizontal and vertical shifts, and then the other 4 trig functions by the end of the week. All right, so typically in mathematics we go one direction. So here I give you the function, you graph it. Yeah, so the other one is find an equation for each graph. Now, when we do this, there's more than one function that would fit for these graphs. Remember I said that cosine and sine only differ by 90 degrees or by pi over 2 radians. So when you come up with a function here, there's different ones you can come up with. I think I might have written one down even here. But we're just going to choose one. Just choose one, that's it. Sometimes in the instructions they'll say, I didn't put anything in this one, but they'll say write a sine function to model or write a cosine function. They have to tell you that, otherwise you couldn't choose, okay? But in this case, when I look at A, just because it's going right through the origin, I'm thinking sine graph when it starts there. It is going to be negative because it's reflected, yeah, and that's the one that I chose when I did it. I chose a sine graph. Let's see if we can identify A and then find B. So let's just go with the sine graph. We have y equals sine of x as our parent graph. If we can figure out what A is, it's like A, we can read right off the graph. Yep, it's this distance here. So A is 2. Somehow we need to find B. We have this relationship, period, equals 2 pi over B. Well, this time we're finding B. So using a little bit of proportional reasoning, would you agree that I can move the b up to where period is, and 2 pi stays where it is, period goes down here, right? A little swapping, or cross multiply and divide. Okay, all I'm doing is swapping the b with the period. It's one of the properties of proportions, one that we use often. So now what I need to do is read off the graph the period and then calculate b, and then I can go ahead and write my function. So I think you can calculate the period there. Let's see. If I start right here, how far do I go before I repeat again? Looks like I go to 4, huh? There's one cycle. So if that's one cycle, then that's the period. So I have b equals 2 pi divided by 4, which gives me a b value of pi over 2. Kind of like one of those examples I had earlier. So it's y equals, now this sine function is reflected, so I need to put a negative in front of the 2. This is to reflect over x. And then I have sine, and the b is right above me there, pi over 2 x, and that's my function. So that would be equivalent to, here you have this set of data points, and you're trying to find a function to model it, okay? Which is what we're going to do when we look at our tides modeling tides. I'll go through the process with you of how to find an equation. And I'll show you how to do it. I can show you on the calculator how to do it. There's something on the calculator that you'll look at in AP statistics if you're in there, where you do what's called a linear regression. That just means you find the line of best fit for a scatter plot. So you have all these points scattered. Of course, the points won't be in a perfect line, but you'll find a line of best fit for it. We can do that with this type of data too. You could have data that's looking kind of periodic. It looks like you could overlay a sine or cosine curve on it. If you hit sine regression, you'll see that as one of the options and use it. We'll come up with a sine equation of best fit. And we can also do that by hand. We're going to do it by hand, and I'll show you also how to do it on the calculator as well. And you can do it with Desmos, all kinds of different computer software as well. All right, this one right here, as I look at this one, just because it starts high up here and goes like this, I'm thinking a cosine curve. That's what I meant for us to use on this. We could use a sine curve, but we would have to then shift it. We haven't talked about that yet. We're going to go with the cosine curve. The amplitude A is 3/4. Doesn't look like there's any reflection. It's just like the parent graph. We know that b is equal to 2 pi divided by the period. And so we got 2 pi over, looks like I put pi out here. So what do you think this is scaled by? Wow, how'd you pick up on that so quickly? Yeah, I tried it. Okay, good. So I've got pi over here. We got 1, 2, 3, 4, 5, 6. So right here is pi over 6. And then this would be 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. So there it is. So it is scaled by pi over 6s. So my period, though, only goes from here over to here. So how do I figure out the period based on that? Just count, right? Or subtract or whatever, but we're starting at 0, so just counting up to 4 pi over 6. So the period then is equal to 4 pi over 6, or 2 pi over 3 if you want it simplified. So plug in 2 pi over 3 here, and then go ahead and solve it. So it's y equals 3/4 cosine. I better figure this out here. 2 pi times 3 over 2 pi. 2 pi's cancel. That gives me 3. So that means b is 3. X. I should put parentheses around that. Show that as all part of the argument. So there's finding the equation given the graph. So you'll be asked to go both ways. That's towards the end of the assignment in here. I ask you to do that. That's it. That's for at least the first two aspects of graphing. We've got to add in the other two tomorrow. So I give you the last few minutes of class here. I'd like you to try something. It'd be great if you could try the matching. I want to also show you how you can use your calculator to check